A particle moves along the x-axis so its velocity v at time t when t is greater than 0 is given by v of t equals sine t squared. The graph of v is shown above for the interval 0 to square root of 5 pi. The position of the particle at time t is x of t, and its position at time t equals 0 is x of 0 equals 5. So part A asks to find the acceleration of the particle at t equals 3. And since they give you the velocity, the acceleration is the derivative of the velocity. And you can plug into the calculator to find the acceleration. So I plugged in the function already. To find the derivative, just plug it in. At x equals 3, so the answer would be a of 3 equals negative 5.467. Part B asks to find the total distance traveled by the particle from time t equals 0 to time t equals 3. To find the total distance, you find the integral of the interval 0 to 3, the absolute value of the velocity d of t. So you can plug that into the calculator. So the answer would be 1.702. Part C asks to find the position of the particle at time t equals 3. To do that, you would find the integral of the velocity. And since they give you position of 0, which equals 5, you would start with 0 to 3 as the interval of v of t dt, which is equal to x of 3 minus x of 0. So x of 3 would equal the integral of 0 to 3 v of t dt plus x of 0. You can plug this into the calculator to find this value. So So x of 3 equals 0.773 plus x of 0 is equal to 5 plus 5. So the answer would be 5.773. The question for part D is, for the interval 0 to square root of 5 pi, find the time t at which the particle is farthest to the right and explain your answer. So this question is basically asking you to find the absolute maximum, and that would give you the particle when it's farthest to the right. So first, you want to find the points which, the critical points of velocity, then v of t equals 0, and when it changes from positive to negative, because that is when it's moving from right to left. And to do that, you can use the 0 function in the calculator. And for that, you would find that the points would be t equals 1.772, 3.070, and 3.963. Those are the points when the velocity is changing from positive to negative, and v of t equals 0, and it changes from positive to negative. So, to find when the particle is farthest to the right, you can make a table to find the greatest value of x of t, and you also need to include the endpoints. So 0, 1.772, 3.070, and 3.963. This is the same thing as the square root of 5 pi. And then to find the values of x of t, You have the equation from part C. X of t is equal to 5 plus the integral of 0 of t v of t dt. You just plug in the values and you would get 5, 5.895, 5.788, and 5.752. So that means the particle is farthest to the left. Farthest to the right when t equals 1.772. The reason why the particle is farthest to the right at t equals 1.772 is because x of t has an absolute maximum at t equals 1.772.